There's an element in the universe, so rare, so unstable, that it might not even survive long enough to be seen. Not even the most powerful explosions in the cosmos, the ones that forge stars, planets, and life itself, can produce this element in visible amounts. On Earth, it exists for just a few milliseconds. And across the rest of the universe, maybe not even that. Today, you're going to discover the rarest element in the universe, and why it probably should never have existed at all. When you look up at the night sky, it might feel like you're seeing the universe in all its glory. But the truth is, you're only seeing the surface. Behind all that light, there's a chemical story unfolding, one that's as violent as it is beautiful. Everything that exists, literally everything, is made of elements. The same atoms that build your body, your phone, the stars, and even black holes. But have you ever wondered where those elements come from? The answer lies in the stars. Literally. At the beginning of the universe, there were only 3 ingredients: hydrogen, helium, and a tiny bit of lithium. That's it. Just 3. Every other element, oxygen, iron, carbon, gold, uranium, was forged later, deep inside the hearts of massive stars. These stars spend millions of years fusing light atoms into heavier ones. Hydrogen turns into helium, helium into carbon, carbon into oxygen, and so on. It's a kind of cosmic alchemy, except it's real. But here's the insane part. This process has a limit. Stars can only go as far as creating iron. When a star reaches iron, that's the end of the line. It collapses under its own weight. And then comes the explosion, a supernova. It's in that moment of destruction that the rarest, heaviest, and strangest elements in the universe are born. Gold, platinum, uranium, and a whole bunch of other weird names from the periodic table. They don't just pop up during normal conditions. They're born in chaos. But not all elements are lucky enough to survive. Some are so unstable, they fall apart almost instantly, as if the universe itself is saying, "You were never meant to be." And that's where the hunt begins. Since the first telescopes were invented, humans have been trying to understand what the universe is made of. Using spectrometers, we analyze the light from stars and galaxies to reveal their chemical signature. Every element leaves a unique trace, like a cosmic barcode. Because of that, we can identify elements from billions of light years away, without ever touching them. But what happens when we find nothing? When an element is so rare, so unstable, that it doesn't even leave a clear trace? It's like looking for a shadow in the dark. We think it might be there, but it vanishes before we can be sure. These are the true ghosts of the periodic table. They appear for a fraction of a second, then disappear before any telescope can say they were real. Even in the most extreme events in the cosmos, supernovas, neutron star collisions, some elements barely leave a whisper. Or they flash, in and out so fast it's like they never existed. And in that darkness between what we know and what we suspect, lies the star of today's story. An element so rare, you might be one of the few people on Earth who's ever heard of it. To understand how rare the element we're about to reveal truly is, we first need to understand how elements are born. And spoiler alert, there's nothing peaceful about it. Everything begins with stars. They're like enormous cosmic furnaces. Imagine a giant sphere made almost entirely of hydrogen, so massive that gravity compresses it with unimaginable force. Deep inside in the core, pressure and temperature reach such extremes that hydrogen atoms begin to fuse, forming helium. This process is called nuclear fusion, and it's what keeps stars shining. But that's just the beginning. Over millions of years, the star starts running out of its light fuel. When the hydrogen's gone, it begins fusing heavier elements. Helium turns into carbon, then oxygen, neon, magnesium, a chemical staircase that leads all the way up to iron. And here comes the critical point. Iron is the limit. Why? Because fusing iron doesn't release energy, it consumes it. So when a star tries to fuse iron, it enters an energetic dead end. The core collapses in on itself, gravity wins, and everything ends in catastrophe, a supernova. That explosion is so violent it turns the entire star into a factory of heavy elements. In that moment of chaos, Gold is born, platinum, uranium, and other exotic things you've only seen on the weird side of the periodic table. But not every element is born like that. Some only appear during even more extreme events, like the collision of neutron stars. These are objects so dense that just 1 teaspoon of their matter would weigh billions of tons. When 2 of them collide, the universe does something almost unthinkable. In a single instant, an absurd amount of energy and matter is released. It's like the laws of physics are being pushed to the edge. And there, in the radiation, gravity, and unimaginable heat, the rarest elements in the universe are forged. But here's the catch. The heavier the element, the shorter its life. Some of these elements are born and vanish in fractions of a second. So unstable, their atoms fall apart before they even get a chance to interact with anything around them. They're almost impossible to detect directly, so they exist, briefly, and then disappear as if they never were. It's like the universe creates a masterpiece and then erases it instantly. Still, scientists here on Earth have managed to recreate some of these ghostly elements in laboratories. Using massive particle accelerators, they force atomic nuclei to collide, trying to imitate what happens inside a supernova or a neutron star smash-up. And through these experiments, we discovered some of the rarest elements in the universe, elements that don't appear naturally anywhere we know of, elements that we only observe for a few milliseconds before they're gone. One of them is the star of our story, an element so rare, so unstable, and so mysterious that some scientists call it the ghost element. But before we reveal what it is, we need to understand why it shouldn't exist, and how its existence challenges the very boundaries of the periodic table. Now we're here, the rarest, most unstable, and most surreal element ever detected. Its name, oganesson, symbol, Og, atomic number, 118, and the story behind it sounds like science fiction, but it's 100% real. This element does not exist naturally anywhere in the known universe. It's never been found in asteroids, stars, nebulas, or on the surface of any planet. It simply isn't part of natural matter, and that alone says a lot. If not even the universe, with its billions of years and billions of galaxies, manages to produce this element frequently, you can imagine just how rare it really is. Oganesson was only ever created artificially. In 2002, Russian and American scientists did something wild. They took calcium, which has 20 protons, and smashed it into a super heavy element called californium, with 98 protons. If everything went perfectly, the collision would create a new nucleus with 118 protons, and it worked. For a ridiculously brief moment, something completely new was born, an element that, until then, only existed in theory, on paper. But here's the insane part. Oganesson disintegrates in less than 0.01 seconds. That's right, less than a millisecond. You can't see it. You can't touch it. It doesn't form molecules. It doesn't make up anything solid. It doesn't react like normal elements. It simply exists and disappears. It's like the universe is saying, here's what I could create, but didn't. The only reason we know it was ever there is because its atoms leave behind a few specific signals when they fall apart. Each trace, each hint, is like a footprint in a desert of possibilities. Even stranger, oganesson may not behave like a noble gas, despite sitting in the same group as helium, neon, and argon. Instead, it might have quasi-metallic properties, and its atomic behavior is still a total mystery. Why? Because quantum physics starts to break down in this realm. These atoms are so large, so loaded with protons, that their electrons behave in unpredictable ways. This is where science reaches the edge of understanding. Creating oganesson was like forcing nature to reveal a secret it wanted to keep buried. And that raises a disturbing question. Could there be even stranger elements that the universe created only once in some forgotten corner of the galaxy, and that vanished before we ever noticed? If oganesson is a ghost that disappears in milliseconds, then osmium is the opposite, dense, solid, eternal, and born among the stars. Osmium is the densest element in the entire periodic table. A cube the size of your fingernail feels like a chunk of collapsed gravity. But here's the catch. There shouldn't be much osmium on Earth. Most geologists agree that it came here the same way as iridium, delivered by ancient meteor showers billions of years ago. That's right. The osmium we find today is, in many ways, extraterrestrial. During Earth's early formation, nearly all osmium sank deep into the core due to gravity. What's left in the crust? Almost nothing. So how do we even find it? Over time, metal-rich meteorites, forged in ancient stellar explosions, bombarded the early Earth, and each one carried small traces of osmium, like seeds from dead stars. Today, finding pure osmium is like discovering dust from long-dead suns, material that has survived billions of years of cosmic chaos. But don't be fooled. Despite its rarity and value, osmium is also dangerous. When oxidized, it forms a volatile, highly toxic compound that can permanently damage human lungs. It's a deadly treasure. Shiny, bluish metallic, but lethal. Still, we use it in high-end technology. Needles for vintage record players, ultra-precise instrument tips, electrical contacts, and even in space-grade superalloys. But here's the wildest part. Osmium only exists because of neutron star collisions, the densest, most extreme events in the universe. When two neutron stars crash into each other, the energy is so enormous that atoms like gold, platinum, iridium, and osmium are forged in mere seconds. Then, they're hurled across space, traveling for millions of years, until they eventually land on planets like ours. Let that sink in. Every gram of osmium once sat at the heart of a star explosion. It was born in stellar death. There are metals that glow in the dark, but this isn't magic. It's pure physics, straight from the heart of the cosmos. We're talking about elements that, even when isolated, emit light. No electricity, no heat. They just glow. The pi. Most well-known of them is tritium, a rare form of hydrogen, a radioactive isotope that gives off a soft bluish glow. It sounds like science fiction, but it's already been used in NASA spacecraft, in control panels, watches, and emergency markers. But the most impressive natural glow doesn't come from tritium or radon. It comes from a process called stellar luminescence. Stars like our sun shine because of nuclear fusion, the merging of elements like hydrogen, helium, and, in more advanced stages, carbon and oxygen. During these reactions, an absurd amount of energy is released, turning ordinary atoms into eternal sources of light. Right now, you're literally surrounded by that light. Every photon touching your face came from a controlled atomic explosion at the center of the sun. In distant galaxies, there are even more exotic elements that emit radiation, like technetium, which doesn't exist naturally on Earth, but has already been detected in red giant stars. So here's the question. Why do these stars contain elements we don't have here? The answer? They created them in their cores, through intense fusion processes. That means there are stars out there actively manufacturing radioactive glowing matter in real time, through processes we've only just begun to understand. And that changes everything. Because maybe the light we see in the sky isn't just the glow of hot gases. Maybe we're looking at atoms that shine because they're in the middle of becoming something else. Atoms that are born, live, and die, just like stars. In the future, elements we currently only use in labs, like tritium, could become key components in fusion reactors, interstellar energy systems, or even the engines of spacecraft. Imagine traveling through space powered by a metal that glows on its own. No fuel, no solar panels, just light and physics. And to think it all begins with a single atom, born from the same energy that lights up the stars. Somewhere out in the universe right now, a brand new atom is being born in the heart of a star. Maybe that atom glows on its own. Maybe one day it'll crash into Earth, riding a meteor. Or maybe it'll power the next spaceship heading into the unknown. Because in the end, everything we are, everything we know, came from atoms that once glowed in the dark. And if that doesn't make you curious, nothing will. So if you're into this kind of journey through the brightest and most mysterious sides of the universe, subscribe to the channel, turn on notifications, and come explore what else the cosmos is hiding out there. Because here, space is never the limit.